Hey there, welcome to your ninth webinar. In this webinar, you're going to have a walkthrough to your second project, which you will build your own machine translation, which it will translate any English text to its corresponding French translation. And hey, congratulations if you came so long. You did a great job. Now you're almost done with two-thirds of the course. And it's just a tiny bit of the way until you successfully finish it. And if you haven't reached out to the schedule yet, it's totally fine. It's very okay. Now is a very great time to actually start to catch on to the schedule and hey, maybe finish the class sooner than others. So that being said, let's start by having a look at our data sets. In here, we are going to use a subset of the data set called WMT, which if you're interested to work with a larger data set or even work with another languages beside English French, you can come here and download it. So let's start by importing our libraries. And in here, two different dataset has been provided for you. The first one is English dataset and the second one is French dataset, which they're just English and French text, which is just a translation, their corresponding translation. And what we want to do is to take this English text and also French text, get their vocabularies, and so later on we can in our neural network define our input and our output. So let's load the data set. You will call this English sentences. And for loading the data set, a file has been provided for you called helper, which it will do everything for loading. The only thing that you have to do is just write helper and dot load data. That is, it will load the data set successfully. And in here you have to say in which directory is your data set, which for me is data dot small vocab English. Let's also load our French dataset. We will call this French sentences. Again, we will use helper.load data. In here, we will define the directory, which is data.small-vocab French. So now we have loaded our both data successfully. We can take a look at our dataset, so see how it actually work. And more specifically, we are going to look at the first item in both dataset. So we will say print first English sentence, then we will go to the next line, so it will be better for seeing. I will say English sentences and the first item. This is a list. This is a list of strings. This is also a list of strings. That's why we can say bracket 0, which it will show the first item in it. Again, let's go to the next line. And in here we will say first French sentence. French sentence 0. And you can see they're exactly equal, but in different languages. So it's very great that we know the type of our dataset and also like how it is structured exactly. After playing a little bit with our dataset, we want to get our vocabularies. What is vocabulary? Vocabulary is a dictionary that as a key we are going to have all of the words, and as a value we are going to have a total number of counts that it has made occur in our dataset. Let's start by getting the vocabulary for our English dataset. We can call this English word counter, For counting, we will use a library called collection, so you can import it. Collections, and we will use counter. Which inside this counter, we will just define a list, and it will automatically create a dictionary, which is value is words, and the key is word, and the value is its count. So let's define our list here. In here we will iterate through these English sentences, and after iterating to it, we will have a second loop, which we will iterate again on the sentences, which is split, and we will get the length of each of it. We will get each word of it. So let's first iterate through the sentences for our first loop. Now also let's have our second loop, which we will get the words. We will get these sentences, and then we will use dot split. And at the end we will just get this word. And that is it. The English word counter, the collection will take care of everything. Now also let's do the same thing for our French word. We will call this French word counter, collections, counter. Inside this we will define a dictionary, which at the first loop we will iterate through sentences in our French sentences. For our second loop we will iterate through the words, and at the end we will just get the word inside this list. Now we got our counter. If you take a look at it, you will see that this is a dictionary, words, and the total amount of counts in English. You can also use the same thing for French, and it will show exactly the vocabularies and their counts. Now let's get the total number of words, English words, that we have. So for this we can say print English words. So we will define a length, and inside this length we will get all of our words like here. So for our first loop we will iterate through sentences in our English sentences. For our second loop we will iterate through words inside these sentences, but split. So we'll get the words, and then we'll get the length of it, which it will show how many English words are there, which is around 1,000,000. Now let's do the same thing for our French words. The length, and inside of it we will again iterate through sentences inside the French sentences. We will have our second loop, which will iterate through words in that sentences. Okay, almost the same amount of words in both languages. Now let's get the unique words. This wasn't unique. This amount of words that we have, they weren't unique at all. In here we want to see how many unique words do we have. So let's print this out. We will say unique, let's not use capital, unique English words. Which in here we'll get the length of this English word counter, because this English word counter, the keys, all of them are unique. The values you show the count, but the keys are always unique, so we can just get the length of that. And we'll do the same thing for our French words. French words. Get the length of this French word counter. As you can see, it's dramatically reduced to 200 and 300 from 1 million words. So it shows that they didn't use too much different words in here. Now let's get the 10 most common words, both in English and also in French. You can say 10 most common words in English dataset. Let's go to the next line. In here, first we will do this. Later we will see why. Then we will add the join. Add the join. Which inside this join, we're going to have a list. And inside this list, zip, which it will somehow append. And we'll get this English word counter. And for this counter system, we use collection counter. We can use a method called most common, which will get just 10. And in here we'll get the 0. And at the end we will again add this. So these are the most common words in our data sets. Now let's take also the most common ones in our French language. We can just copy paste this. French dataset. In here we'll just use French word counter. And these are the 10 most common French words. Okay, very great. Now you have done with loading the dataset. We will take a look at it. We saw how many words are there. We saw how many unique words are there. We also saw the most common one. After the first step finish, we will go to the pre-processing. So in pre-processing part, you only need to do two things in order to finish it successfully. The first part is to finish this tokenize function, which it will take care of all of the pre-processing. Later on, we will see how we can use Keras, just one line of Keras, to take care of all of the pre-processing. And the second part of the pre-processing part is just finishing the padding function, which it will take care of the length of our dataset. Because as you know, some sentences might be short, some might be long. And in here, we have to define a constant amount. Like if it was shorter, we will pad it with zeros. If it was longer, we will just cut it. So let's start by how we can write this tokenized function. And for it, as I said, we will use something from Keras. And if you go to the website and go to the text preprocessing, you will see it at the very start, the tokenizer. You will first import this, and then you will initialize it. You will just say like token equal to tokenizer, for example. And inside this, as you can see, we have some argument, we have some parameters. The first one, it just will take care of the word frequency. For example, you define the maximum amount of words that are allowed to stay, which is mostly related to its occurrences. Filter is for removing all of the punctuation. As you can see, you can define it. It's already been defined, so you do not need to write anything if you want to delete all of the punctuation. And then you have lower, which it will lowercase it. Then dot split, which it will tokenize it. Also, it's a character level. If you there's whether you will use work level or character level, which character level is HTHIS, it will work like that. So if it you put true, it will work like that. So let's come back to here. So first you will initialize it, then you will fit to text, given text, which is X here. Then you will use this tokenizer to convert the text into sequences, which you will just that fitted tokenizer, you will put dot text to sequence, and inside the parentheses you put X, and you will return it. And as our second thing that you'll return is the tokenizer itself. After doing this, you'll finish all of these tokenized functions successfully. Secondly, for padding, let's go again to our Keras website. This time, go to sequence preprocessing. And if you go down, you can see exactly. So after importing it, in here you will put sequences, maximum length that is allowed, which if it's more than it will cut it, if it's less than it will add 0 to it. So let's come back to here. At the very start, we have X and also length of none. At the very start, we want to assign length automatically if it's still none. So how we do it is using an if statement. We will say if the length is none, then inside the if statement you will say initialize an empty list here. Then you will iterate through the given sequence, which is this, and you will take length of each of it. This list, you will iterate through it and you will get the length of it. Then you will append it to this empty list. After that, you will take the maximum amount in that length. You will just put max parentheses, and inside that you will put that list, which is a list of length, and you will take the maximum number and you will assign it to the length. And the second part is just we will apply the path sequence to X, then you will return it. That is all. If you do this, you will successfully preprocess it and you also pad it. The next step and the third one is to build a model. In here we will create 5 different models. The first one is a simple RNN, which we will just make a very simple architecture using whether LSTM or GRU. The second one, we will add the embedding to this simple RNN to see how's the prediction will be, how the accuracy will be. The third one, we will add bidirectional to this model 2. The model 4, we will use encoder decoder, which is for sequence to sequence model. And this is optional, so if you don't want it, you can skip it. But this is very great if you can do it. And the last one is a custom model. What does this mean? Is we will combine all of these 1 to 4, the ones that give the highest accuracy, we will combine it and we will create a very powerful custom model, which can literally have the same power as a Google translation. So let's start by the first model, which is a simple RNN. For creating a simple model, you can literally make a lot of different architecture. It's really up to you. In here, I will just define one of them, and same thing as other architecture. They're just one of the many kinds, so feel free to use also your own. And in case of the simple RNN, at the very start I define the input sequence, which you can see this in here. If you go to the core layers, in here you can see the input, which you will just define the input, and inside of it you define the shape. And for the case of shape, it's just the input shape without considering the first dimension, because it's just a training exam that doesn't make sense. So it is a, you'll define input sequence with the same shape as this input shape without considering its first dimension. After defining your input sequence, you will add a RNN layer. It can be either LSTM or GRU or so. It's very depends on you to which one to choose. And one important thing to note, after defining your this RNN layer, be careful to return the sequences and put it as true. You can also, for your third step, you can define the same thing as this. You can just copy paste this GRU layer, then add it, which again it will return the sequences as well. And at the end you want to add a output. So this output, the total number of units is going to be French vocab size, and you will define a softmax activation. At the end, you will just use this keras models.model to somehow connect this input to the rest of the layer. And at the very end, you will just compile it, which it has already provided for you. Then you will return it. And that is it with a simple model, as simple as that. So for your second model, you want to literally do the same steps that you did in your simple RNN functions, but with one difference, that you will add an embedding. So again, you will define an input sequence. Then as your second step, you will add embedding, which you can take a look at embedding in here. Once again, this embedding layer. If you look at it for defining an embedding, at the very start we will define the input dimension, which this input dimension is just our embedding size, which is been, so this is the embedding size, which you can define it your own. The second one is English vocab size. It's very important to remember. Output is English vocab size and it is not French vocab size. And we will don't touch anything rest of it. Everything looks great. And after defining this embedding, we will again define a RNN layer which returns the sequences. And again, we will define another GRU layer which will return the sequences. And then we will define output using a dense layer, and we will use keras models.model for connecting this input with the rest of the layers. And at the end we will just compile it and we will return it, and we will have our embedded model. And after creating your embedded model, don't forget to reshape before putting the dataset into our embedded model. At the very start, reshape the model so you can actually put it into this architecture. Then you will initialize this embedded model. Then you will train it, and at the very end you will print predictions. So for your third model, you want to add bidirectional RNN and make just a few tweaks to your second model. So again, we will define an input sequence. Then we will add the embedding as we discussed in a second model. Then we will add the bidirectional layer, which is wrapped around the GRU layer. Let's look at this bidirectional layer in Keras so we know exactly how it works. So we will go to layer wrappers, and in here, if you take a look at this bidirectional, you will see that they define a bidirectional. Then inside this bidirectional, they define a RNN layer, and that is exactly what you want to do. You'll define a bidirectional, then inside of it you will exactly write down the GRU layer that you were defining before. So that's what does it mean, a bidirectional layer wrapped around an RNN layer, LSTM layer, or GRU layer. So that's exactly what you're gonna use. You will use the same GRU layer that you were using in your first and second model. Then you will put a bidirectional around it. Again, you will repeat these sentences in here for your first step. And for your output, you will again use your dense layer, which a time distributed layer is wrapped around it. Again, if you go to this layer wrapper, here is time distributed, which you will define your time distributed, and inside you will define your dense layer. And this is exactly what you should do. For your sixth step, you will define a chars.models.model. So you will connect all of these layers together, and then you will compile it, and then you will return it. And before training this model, you will reshape the input, initialize this model, BD model, bidirectional model. Then you will fit it to this reshaped input. Then you can print the predictions. So now let's go to your fourth model. For your fourth model, it is optional, which in here you have to build a sequence-to-sequence model. And more specifically, each sequence-to-sequence model includes the encoder and also decoder. And if you want to build this model, like all of other models, you'll define input sequence. Then you will define a GRU layer, which you will call it your encoder. One difference in here is that it does not return the sequence. Before we were returning it, but in here we don't return it. And we've put this equal to encoder. Before we put this encoder to our decoder, we want to use this repeat vector layer. So it will change its dimensionality, because we want to this will return a 2D output. However, we want 3D before we putting it in our decoder, and that is exactly what repeat vector will do. And this is the same thing that Keras has been provided. So we'll use this to convert this 2D output to 3D. After converting, you will create your decoder, which is again a GRU layer that exactly like the same layer that you were creating before. This time it will return the sequences, and that is how you create this encoder decoder. And later you can add an extra dense layer, and then you will add your output layer, which this output layer again is a time distributed layer which is wrapped around the fully connected layer. Then you will use chars.models.model to connect all of these layers together. You compile it, then you will return it. And like any other models that we will work on, you will reshape it, initialize this encoder model, fit it to this reshaped input, then you will print the prediction. So for your last model, you want to create a custom model. What does this mean? You have to go back and take a look at all of these four models that you have created, and you have to see which component help you to increase the accuracy of your model, and which component on the other hand made the model to decrease in the accuracy. So at the end, you want to create a custom model that you can sum up everything you work on, and this custom model will show you very high accuracy, higher than any of these four. So What I did for my architecture, I used the first input sequence. Again, I use the embedding layer. I created my encoder, which is a bidirectional layer wrapped around the GRU layer. Also, side note, encoder doesn't return sequences. After creating my encoder, I used repeated vector to change the dimensionality of this encoder from 2-dimensional to 3-dimensional. After doing that, I use my decoder, which my decoder is a bidirectional layer wrapped around a GRU layer. Side note, decoder does return sequences. Then I add an extra dense layer, which is a time distributed layer wrapped around the fully connected layer. At the very end, I made my output, which my output is a time distributed layer wrapped around the fully connected layer. But of course, the output is the French vocabulary size. So after creating that, you have your final model. For now, in this part, you will not train it. You will go to this prediction for training. So let's go to your last part, prediction part. In your prediction part, you just need to do 3 things to finish everything successfully. At the very start, you will reshape the input to work with embedded RNN. How you do it is to use this pad function that you build at the very start. You will use this to reshape it so you can work with it. After reshaping it, you will initialize this final model inside here. And for your third step, you will fit that in your X and Y dataset. After that, the rest of thing has been provided for you. It will train it. It will show you the accuracy, and at the very end also it will do some prediction for you. And with your final model, you can reach to a very high accuracy, and you will reach to around more than 98% for both your training and your testing set. And the amazing part is that we are just using a very small data set. We didn't use the whole data set. Imagine what would be happening if we use a larger data set, which you can find it in this website. And that is it. Now you have created your own machine translation, which has a Google, which has an accuracy same as Google. And if you're interested to learning more different approaches, different ways, you can check out these resources. It's a great way for deepening your understanding. Thank you very much for putting your time in this webinar, and see you in the next webinar.